Okay, so we've gone through and we have talked about exponential growth versus exponential decay. We've talked about some basic evaluations of logs. I've got exponential growth, y equals 10 to the x power, and I've got its inverse, which would be log base 10, or known as common log. Whenever that log doesn't have a base written, it's assumed that it's 10. So, just going to start off with a couple of things here. If I got x and then 10 to the x power, I'm going to put in -2, -1, 0, 1, and 2. So 10 to the negative second power just gives me a fraction of 1 over 100. Okay, 10 to the negative first, 1 over 10. Okay. Okay. If I'm talking about log, inverse means that all of these y values will take the place of x. So 1 over 100, 1 over 10, 1, 10, and 100. And these x values will take the place of y. So -2, -1, 0, 1, and 2. Okay. We really haven't talked about that in that way, but we did when it's talking about rewriting a log or rewriting a function as an inverse. I say to take and rewrite x and y, switch their spots, and do the Freaky Friday move. Take x and y, they're going to switch positions, and then we're going to solve for y. Well, to solve for y, what we would do is write it in exponential form. So here is the base. Here's the exponent, and y is what it's equal to. Okay? Switch that with y, do our Freaky Friday thing, and I'm going to have x equals log base 2 of y minus 1. Now I can't add 1 until I break this y minus 1 out of the parentheses, and I'll do that by saying that here is my base, here is my exponent, and we'll make that 2 to the x, or equals y minus 1. Add 1 now, and I get 2 to the x plus 1 equals y, and there's my inverse. So I started off with log base 3, I end up with base 3. Start off with log base 2, I end up with a base 2. So here, recall, from graphing exponential growth, my base is 2, so I'll put -2, -1, 0, 1, and 2. That's going to be 1, 2, so 1/4, 4. That's 2, so 1/2, and 1. Go over to the left 2 and up 1/4. Go over half, 1, 2, and 4. Looks something like this. Where my domain would be all real numbers, and my range is y is greater than or equal to 0. I have an asymptote. Okay, it's never going to touch the x-axis. Going to come really close to that. So at y equals 0. In fact, it is a horizontal asymptote because it's going left to right. Okay, now I'm going to use that same concept, but I'm going to graph log base 2. Okay, so what's going to happen is all of my x values were -2, -1, 0, 1, and 2. They're now going to become my y values. Okay, so right here are all my x values, -2, -1, 0, 1, and 2. All my y values, the 1/4, 1/2, 1, 2, and 4, are going to become my x values. So now I'll go over a little bit and go down 2. Go over a half, down 1. 1, 0. Okay, go over 2, up 1. Go over 4, up 2. And now what it's kind of unique is my domain range has kind of changed. My range up above was y is greater than or equal to 0. Well, now my domain is going to be x is greater than or equal to 0. Okay, because now I'm going to have a vertical asymptote. So now it's going to be the y-axis. So x equals 0. And my range is now all real numbers. Now, I picked exponential growth, so y equals 2x for my table up above, because this was base 2. Okay, if it was base 3, then I would do 3 to the x. If it was base 10, I would go 10 to the x. All right, so anyways, we've got this whole moving logs exponential around, so I'm going to put an a out in front of the log base 2 inside of the parentheses and outside of the parentheses. This number will move it to the left or the right. This number will move the graph up or down. Okay, now my parent table is going to be the same table as the one up above. Okay, so because that 2 is inside parentheses, I'm going to move everything to the right too. So I'm going to plot from there. Well, that's going to move my vertical asymptote to x equals 2. And from here, I'm going to go over a fourth, down 2, over a half, down 1. And it's going to look like this. Where my domain is, x is greater than or equal to. Now we moved it, so it's now 2, not equal to, sorry, just greater than 2. Better check to see if I put it equal to. Yeah, I don't want it equal to. Greater than 0. Okay, and my range is all real numbers. Okay, put the plus 3 outside of parentheses and it's going to move it up 3. So now my starting point is going to be up 3, and it's the same parent function. So from there, negative 2 down, and it looks something like this. But see, notice how I didn't move it left or right. My vertical asymptote is still going to be at 0. So my domain is still going to be bigger than 0, and my range is all real numbers. There we go. Now, what I want to stress is if I were to change that into a, say, 4, and I made that a 4, I wouldn't use 2 to the x, I would use 4 to the x. So it's going to change those numbers. Hopefully that you get the idea after the one. If not, we'll practice that more in class.